If you're building a multi-tenant SaaS application on Azure and your customers are asking for private connectivity, you need to stop giving them VPN tunnels or VNet peering right now. I just helped a company eliminate 47 separate VPN connections and save over $8,000 a month by implementing Azure Private Link Service instead.
Wait, $8,000 a month just on VPN connections? That seems like a lot for something that should be straightforward.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm your host, and with me today is Alex, who's been building out a SaaS platform and running into this exact problem.
Hey everyone. Yeah, I've been getting requests from enterprise customers who want to connect to our service without going over the public internet, and I honestly didn't know where to start.
Perfect timing then, because today we're going to break down Azure Private Link Service and show you exactly how to expose your application privately to customers in completely separate Azure tenants.
So what's the actual problem here? Why can't I just give customers a private IP address and call it a day?
Here's the thing, your SaaS application lives in your Azure subscription, your VNet, with your IP address space. Your customers' workloads live in their subscription, their VNet, with their IP address space. These are completely isolated by design. There's no automatic way for traffic to flow between them privately.
Right. So traditionally you'd set up net peering or a site-to-site VPN to connect them?
Exactly. And both of those approaches have serious problems for multi-tenant SaaS. VNet peering requires non-overlapping IP ranges. If you're using 10.0.0.0 out of 16, and your customer is also using 10.0.0.0 out of 16, which happens constantly because everyone defaults to RFC 1918 ranges, peering simply won't work. Plus, peering is bidirectional. Your customer can potentially see your entire network, not just the service you want to expose.
That sounds like a security nightmare for a SaaS provider with hundreds of customers.
It absolutely is. This is where Azure Private Link Service comes in. Think of it like running a private postal service. You're a business that wants to receive mail from specific customers, but you don't want to publish your actual street address. Instead, you set up a private PO box that only approved customers can send to. The postal service handles the routing, and your real location stays hidden.
So the PO box is like a private endpoint, and the postal service is Azure's backbone network?
Exactly right. Let me validate that analogy with a technical reality. When you create a private link service, you're essentially creating that PO box. It sits in front of your Azure Standard Load Balancer and generates a system-assigned alias. The format is a GID followed by the region and Azure.Private Link Service, something like 12,345,678, 1234 to 1234, 1234, 123456789 API.Westus2.Azure.Private Link Service. Your customers create a private endpoint in their VNet, which gets an IP address from their address space, say 10.1.0.5. When they send traffic to 10.1.0.5, Azure's backbone network routes it through the private link service to your load balancer. The customer never sees your actual IP addresses, and you never need to know theirs.
Hold on. So the IP addresses can overlap? My customer and I could both be using 10.0.0.0 out of 16 and this still works?
That's the magic. Azure performs NAT, network address translation, at the private link service boundary. Your load balancer sees traffic coming from a NAT IP range that you configure, not from the customer's actual IP. This completely eliminates the overlapping IP problem that kills VNet peering.
Okay, walk me through actually setting this up. What do I need on my side as the SaaS provider?
First, you need an Azure Standard Load Balancer, not basic, it must be standard SKU. Your application backends sit behind this load balancer. Then you create the private link service resource and associate it with the load balancer's front-end IP configuration. In the Azure portal, you go to Private Link Center, then Private Link Services, and click Create. You specify the load balancer, the front-end IP, and critically, you configure the NAT IP addresses.
What's this NAT IP configuration about?
You need to specify a subnet in your VNA that Private Link Service will use for source NAT. When customer traffic arrives, the source IP gets translated to an address from this subnet. I recommend creating a dedicated subnet just for this purpose. For example, if your VNA is 10.0.0.0 out of 16, create a subnet called Private Link NAT at 10.0.255.0 out of 27. Now, keep in mind that Azure reserves 5 addresses in every subnet, so a /27 gives you 27 usable addresses, not 32. Each NAT IP can handle roughly 64,000 concurrent connections based on port availability, so Microsoft actually recommends at least 8 NAT IP addresses for production workloads to ensure adequate capacity and redundancy. Size your subnet accordingly based on your expected connection volume.
Got it. So once I've created the private link service, how does my customer actually connect to it?
You share the alias with them, that GID-based string I mentioned. They go to Private Link Center in their Azure portal, click Private Endpoints, and create a new one. They select Connect to an Azure resource by resource ID or alias, paste in your alias, and choose which of their subnets should host the private endpoint. Azure assigns an IP from their subnet, and they're connected.
But wait, can anyone with that alias just connect to my service? That seems risky.
Great catch, and this is where people make their first big mistake. By default, Private Link Service requires manual approval of connection requests. When a customer creates a private endpoint using your alias, you see a pending connection request in the Azure portal under your Private Link Service. You must explicitly approve it. You can also configure the visibility settings on your Private Link Service to control which subscriptions can even see your service, and set up auto-approval for specific subscription IDs if you want to streamline onboarding for known customers. These controls are managed directly in the Private Link Service's visibility and access configuration.
What's the second common mistake you see?
Forgetting about DNS. When your customer creates a private endpoint, they get an IP address like 10.1.0.5 in their VNet, but your service probably has a public DNS name like api.myservice.com. If they resolve that name, they'll get your public IP, not their private endpoint IP. Now, this is different from connecting to Azure POS services, which have standard private link DNS zones like privatelink.blob.core.windows.net. For your custom private link service, there's no standard zone. You and your customer need to coordinate on DNS. Typically, the customer creates a private DNS zone matching your service's domain, like myservice.com, and adds an A record pointing api.myservice.com to their private endpoint IP. Without this coordination, traffic goes over the internet even though the private endpoint exists.
Let me make sure I've got this. As the SaaS provider, I create a standard load balancer with my app behind it, then create a private link service pointing to that load balancer with a dedicated NAT subnet sized for my connection needs. I share the alias with customers, use visibility settings to control access, approve their connection requests, and we coordinate on DNS so they can route traffic to their private endpoint IP.
Perfect summary. One important architectural consideration. If you need to see the customer's original private endpoint IP for logging or tenant identification, you can enable TCP Proxy Protocol v2 on your private link service. But I want to be clear, this isn't a simple checkbox. When you enable it, Azure prepends a binary header to each TCP connection containing the link ID and the consumer's private endpoint IP. Your backend application must be explicitly configured to parse this header. Many applications don't natively support proxy protocol, so you'd need to add a proxy layer like HA proxy or Nginx in front of your application. This is a significant architectural decision you should plan from the start, not bolt on later.
This is really powerful. So I could have hundreds of customers, each with their own private endpoint, all connecting to my single private link service?
Exactly. Each customer gets network isolation. You avoid IP conflicts entirely, and you maintain a single point of ingress to manage. For pricing, you pay for the private link service by the hour plus data processing charges for inbound and outbound data. Rates vary by region, so I'd recommend checking the Azure pricing calculator for current numbers rather than relying on any specific figures I give you today, since pricing can change.
So to recap, Azure Private Link Service solves the multi-tenant private connectivity problem by creating a one-way, NAT-based connection that eliminates IP overlap issues. Customers create private endpoints in their VNets, you control visibility and approve the connections through the private link service settings, and Azure's backbone handles the routing without exposing your actual network.
Nailed it. My final tip, make sure you're using the visibility configuration on your private link service to maintain a subscription allow list. This controls which subscriptions can discover and request connections to your service, giving you governance at the service level. Combined with the approval workflow, you have solid control over who can connect.
This is going to save me so much complexity compared to managing dozens of VPN tunnels.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone building multi-tenant SaaS on Azure. This is a game changer for enterprise customers.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.